In this problem, we're being asked to use the sum formula for tangent. But instead of being given the degree or radian measure of an angle and having to figure out how to build that out of our nice angles, we're being given some information about the two terms in our sum. Now, I know that tangent of u plus v is this fraction. Tangent u plus tangent v over 1 minus tan u tan v. We derived that a couple videos ago. What's going to happen now is I'm going to remember that for the next week, and then I'm going to forget it again, but I know how to derive it. Okay. So remember, you are responsible for being able to derive it. Okay. I do recommend anytime you're using a formula that you write out what the formula is before you plug into it. Because as I'm assigning credit, there's partial credit for getting the formula right. And then there's partial credit for using it correctly. If you're using the wrong formula, but you use the wrong formula correctly, or if you use the right formula, but you use it incorrectly, I want to be able to give you partial credit for the part that you did right. And that's a lot easier if you show me step by step. Okay, so I basically need to know tangent of u and tangent of v. I don't have that information, but I have enough information to figure it out. Okay, I know that sine of u is negative 3/4, and if u is between pi over 2 and pi, that's putting u in quadrant 2 here. Okay, so I'm going to just let alpha be its reference angle here, and if I'm trying to evaluate tangent of u, I can do that as my usual two-step process. We're in quadrant 2. Tangent's going to be negative. Okay. Then I'm going to draw a right triangle with my reference angle in it. Now I know that sine of alpha would be the absolute value of negative 3/4. That would just be 3/4. Okay. So I can label the opposite side 3 and the hypotenuse 4. Be very careful. Sometimes people see a 3 and a 4 and they say, oh, the third side is 5. Because we do have a special right triangle whose side lengths are 3, 4, 5. It's one of the very few that we can have all integer sides. But the biggest side has to be the hypotenuse. The hypotenuse here is 4. There's no way this leg could be bigger than the hypotenuse. So I'm going to just call this a for adjacent, and then I'm going to use Pythagoras. So I know that a squared plus 3 squared would be 9 is equal to 4 squared, which is 16. So a squared is going to be 7. So a is positive root 7. And again, it's not necessary to write that plus sign. I'm just physically writing that to remind myself that algebraically there would be 2 answers, but this was a geometry problem. Okay, so now if I wanted to calculate tangent, the absolute value that I'm going to attach to this negative sign is going to be 3 over root 7. And of course, with the radical in the denominator, I want to rationalize that. So we'll multiply by 1 in the form of root 7 over itself. And so we get negative 3 root 7 over 7. So that's my tangent of u. What I'm going to do is I'm just going to plug that into the formula so that then I can erase this work and we can figure out tangent of v. Okay. So we're going to have negative 3 root 7 over 7, plus I still have to figure out what tangent of v is. That's what's going to go here, over 1 minus tangent of u, we said was negative 3 root 7 over 2. And we've got to figure out what tangent of v is, and that's going to go here as well. Okay, so let's now figure out tangent of v. So let's see, v is between negative pi over 2 and 0. So v was a negative acute angle. So v is this angle that we get by rotating this way. Its reference angle alpha would be that same amount of rotation, just counted in the positive direction. Okay, so we're in quadrant 4. So if we're calculating tangent of v, since we're in quadrant 4, I know that's going to be negative because tangent is negative in quadrant 4. Okay, and then I know that cosine of my reference angle is the absolute value of 1/3, which is actually just 1/3. Okay, cosine in this case of v and alpha are exactly the same. We would have 1 and 3, adjacent over hypotenuse. So I need to solve for the opposite. It's another use of Pythagoras. 1 squared plus p squared is equal to 3 squared, which is 9. I'm just going to write 9. And 1 squared, of course, is 1. So p squared would equal 8. P would equal the positive square root of 8. I can simplify that because that's the square root of 4 times 2, and the square root of 4 simplifies. I can say that's 2 root 2. So tangent of v is going to be negative 2 root 2. So now I can fill that in here. Negative 2 root 2, negative 2 root 2. Now, when we use the sum or difference formula for tangent, there's a lot of simplification to do before we're finally done. Because you'll notice I've got a complex fraction. I've got fractions on top and fractions on bottom. I want to have just a simple fraction. I've also got roots on the bottom, and we're not allowed to have roots on the bottom. So the sum and difference formula for tangent generally are going to require a lot of simplification. Okay, so let's just start out by getting rid of these parentheses and doing that multiplication. So I've got negative 3 root 7 over 2 minus 2 root 2 over 1, and then I've got 1, 2, 3 negative signs here. So it's still going to be subtraction. Okay. But let's do that multiplication. Looks like this 2 will cancel with that 2. That's kind of nice. Okay. And then let's see. We've got root 7 times root 2 would be root 14 with that 3 in front still. Okay. So we've got a 1 minus 3 root 14 on the bottom. Still a complex fraction because I have a fraction on the bottom here. Okay. So I think what I'm going to do is I'm going to deal with the complex fraction first. Now there are a couple of ways that I could do that. One is I could create a common denominator on the top and do that subtraction, and then I just have a fraction divided by this, and I could rewrite this as multiplying by the reciprocal. It's generally easier, though, to simplify a complex fraction by multiplying by 1. I'm going to multiply by 1 in the form of everything that I want to cancel. What I want to cancel is this internal denominator. So I'm just going to multiply this by 1 in the form of 2 over 2. Now when I do that, I'm going to bump up here with my result. I've got to distribute this 2 to each piece on top. Now when I distribute the 2 to this first term, it's going to do what I want. It's going to cancel that 2. So I'm just going to have minus 3 root 7. Okay. But then I distribute the 2 to this piece, so that's going to become minus 4 root 2. Okay. And then on bottom, I've got to distribute the 2. So 2 times 1 gives me 2. And then I multiply it by the minus 3 root 14, so I get minus 6 root 14. Okay. We just combine the parts that are not under the radical, and that tells me how many copies of root 14 I have. Okay, so now I no longer have a complex fraction. I do have these roots. Looks like none of these roots at this point are going to simplify. There aren't any perfect squares that I can pull out at this point, but I do have roots in the denominator, and we don't want to have roots in the denominator. So I'm going to copy this over here just so I have a little bit more space. The way I'm going to clear that is I'm going to rationalize the denominator. We do that by multiplying by 1. We do a lot of things by multiplying by 1. So I multiplied by 1 in the form of 2 halves to clear the complex fraction. To clear the root in the denominator, when I've got 2 terms and one or both of them involve roots, I'm going to multiply by 1 in the form of the conjugate over itself. The conjugate is the same 2 terms, so a 2 and a 6 root 14 connected with the opposite sign. So I'm going to multiply by 1 in the form of 2 plus 6 root 14 over itself. I'm going to multiply out the denominator first so that we can remind ourselves why this is a useful thing to do. Okay? I have to FOIL because it's 2 terms times 2 terms. So 2 times 2 gives me 4. My outsides and my insides are exact opposites of each other. So they'll both contain root 14s, but they'll contain the opposite number. I'll have positive 12 and negative 12 copies of root 14. Those go away. And then my last terms, it's going to be a negative, because it's a negative times a positive. 6 times 6 would give me 36. Root 14 times root 14 would give me 14. So I'm getting 36 times 14. Let's work that out. That is 504. So I'm getting 4 minus 504. Obviously, I can simplify that to negative 500, but notice there are now no roots in the denominator. Okay. So that's why using the conjugate works, because it gives you a difference of 2 squares, but those 2 squares then aren't going to contain any square roots. All right, now on top, we also get to FOIL this out. So first terms are going to give me negative 6 root 7. Outsides are going to give me negative 18 square root of 7 times 14. I'm not going to bother to multiply out 7 times 14 because I can see that 14 is a 7 times 2. So I'm going to have a 7, and a 2 under there. I'm going to be able to pull out that 7. I will be able to simplify this root. Okay. Let's finish the FOILing, and then we'll come back and simplify the roots. Okay. So that was the outsides. The insides are going to be negative 8 root 2. And then my last terms are going to be negative 24 root 28. That 28, of course, is 14 times 2. I'm going to be able to simplify that one as well. I went ahead and multiplied it out because I can do that one in my head, whereas 7 times 14 I'd have to think about. Okay, so now let's see what we have. All right, I've got negative 500 on the bottom. Negative 6 root 7 isn't going to simplify. There are no perfect squares under that. But this negative 18, 7 root 14, let me just come over here and work with that. Negative 18 root 7 times 14. That's the same as negative 18 root 7 times 7 times 2. So there are 2 7s. That's a 7 squared under the square root. I can pull that out. But everything was connected by multiplication, so it's still connected by multiplication. So I'm going to have negative 18 times 7 times root 2. So what's 18 times 7? Negative 126 root 2. That's my next term. Okay, minus 8 root 2. Oh, that's so exciting. That doesn't simplify. Okay. And then minus 24 root 28. That is going to simplify because I can see negative 24 root 28. That's negative 24 root 4 times 7. But I can simplify the root 4. So that's going to become negative 24 times 2 root 7. So that's negative 48 root 7. Okay, we've still got some work to do because now I can combine like terms on top. Okay, so let me just keep this. I'm going to erase the rest of the board here so that we've got some room to work. So if I combine the number of root 7s that I have, see, negative 48 and negative 6, that's going to be negative 54 root 7. And then the number of root 2s that I have. Here I have negative 126 of them. here I have negative 8 of them. That's going to be minus 134 root 2's all over negative 500. We're almost there, but we're not done. Okay, I've got a simple fraction. I've dealt with all of the roots. So there are no roots in the denominator, and all of the roots were simplified as much as possible, and then I combined like terms. But this is a fraction, and fractions need to be in lowest terms. Now, I cannot cancel the 500 with just the 54 or just the 134. But I can cancel if there's something that I can factor out of the top. If there's something that's in both terms that I can factor out, then I might be able to cancel. And both of these numbers are even. So I'm going to factor out, they're also both negative, so I think I'm going to factor out a negative 2 from the top. Okay. Then this will become 27 root 7 plus, because I factored out that negative, let's see, 67? Yes, 67 root 2 over negative 500. Cannot cancel across addition or subtraction, but that negative 2 is connected to the rest of the top by multiplication. Once something's connected to the rest of the top or bottom by multiplication, I can cancel. So those negatives will cancel, and 2 goes into 500 250 times. So that's going to be 27 root 7 plus 67 root 2 all over 250. That is my final simplified answer. Okay. A lot of algebra there. Okay. You'll notice it was tedious. You'll notice we did it all without a calculator. Okay. It's going to be tempting to skip some of the simplification. It's going to be tempting to pull out a calculator. I'm going to expect you to be able to do these questions without a calculator on proctored exams and quizzes. Now, I can monitor the problems and not make them too atrocious, but this wasn't too atrocious. It was tedious, but it was manageable. Okay, so do make sure that you are practicing these things and practicing these skills without a calculator.